Welcome to my YouTube channel, A Binary of Civil.
Today I am going to solve the sixth assignment of Strength of Materials. The first question is, a hollow steel shaft has inner and outer radii as 20 mm and 25 mm. So that is, outer radius is 25 mm. So the diameter will become 50 mm. Small r is 20, small d is 40 mm. It is subjected to a twisting moment T is equal to 400 Newton meter. Maximum shear stress in the shaft is, and we know the formula, T by J is equal to tau by R. So T is 400. I am converting Newton meter into Newton mm, that is into 1000. J is equal to pi by 32 d power 4. So that is external diameter power 4 minus internal diameter power 4. That is equal to tau divided by R is equal to d by 2. That d by 2 is external diameter by 2. So it is 50 by 2. So you will get tau is equal to 27.6 MPa. So answer D for question number 1. Coming to next question. In a shaft of length L is equal to 1 meter is 1000 mm. Twisting moment T is 300 Newton meter. That is 3 into 10 power 5 Newton mm. Modulus of shear modulus, that is G he has given, it is 77 GPa. That is 77 into 10 power 3 Newton per mm square. So cross section of the shaft is same in question number 1. Okay, the external diameter, internal diameter are same as they have given in question number 1. Now twist per unit length, that is theta, we need to calculate, and we know the formula, T by J is equal to G theta by L. From this expression you will get theta is equal to TL by GJ. So theta is equal to T is 3 into 10 power 5, L is equal to 1000 mm, and G is equal to 77,000, J is equal to pi by 32, 50 power 4 minus 40 power 4. So you will get it is 0.0107 radian. So now this radian I need to convert it into degrees. So theta is equal to 0.0107 into, you need to multiply when you are going to convert radians into degrees is 180 by pi. So I will get 0.613 degree. Clear? Answer D for question number 2. Coming to question number 3. A solid circular shaft is expected to transmit power P is equal to 250 kilowatt. So that is equal to 250 into 10 cube watt. While turning at 1.5 revolutions per second, that is N is equal to 1.5 revolution per second. 1 revolution per second is equal to 60 revolutions per minute. So here 1.5 into 60, you will get it is 90 RPM. So from this expression, and maximum tau allowable is 45 MPa. So the diameter of the shaft required is, you know, one formula P is equal to 2 pi NT divided by 60. So power P he has given as 250 into 1000. 2 pi N is 90. T he has not given, we need to calculate. So we will get T as 26525.82 Newton meter. So this is the value of T. Now tau is equal to 16T by pi d cube. So tau he has given as 45 into 10 power 6 Newton per meter square, and 16T as 26525.82 divided by pi d cube. So in this expression the only unknown is D value. So D you will get it is 0.144 meter, that is 144 mm. So the answer is A for question number 3. Coming to question number 4. Torsion is applied to a circular shaft in a twist 3 degrees. So theta is equal to 3 degrees he has given. So Actually, in the formula, you need to substitute the value of theta in terms of radians, not in degrees. So, 3 degrees into, whenever you need to convert from degrees to radians, it is reverse of 180 by pi, that is pi by 180. You will get it is 0.0525 radians. And now length L is equal to 1 meter, and tau max, that is maximum allowable shear stress, is 120 MPa, and G is equal to 80 GPa. Okay, so now radius of the shaft R is equal to question mark. So we have a formula T by J is equal to G theta by L is equal to tau by R. So G is 80 into 10 power 3, theta is equal to 0.0525, L is equal to 1000, tau is 120 divided by R. R is equal to 28.57. This value is same as 90 divided by pi. Okay, so option D for question number 4. Coming to question number 5, the diameter of the shaft is increased from 30 mm to 60 mm. How many times the torque will increases? So from the expression T by J is equal to tau by R. So T by J is equal to pi d power 4 divided by 32 is equal to tau R is equal to d by 2, d and d cube. So in this expression, T directly proportional to d cube. So that is T2 by T1 is equal to D2 by D1 whole cube. So D2 is 60, D1 is 30 whole cube. That is 8. T2 will become 8 times T1. Okay. So when you are increasing the diameter from 30 mm to 60 mm, the torque value increases by 8 times. Clear? Option C for question number 5. Coming to question number 6. A solid circular shaft of diameter D and length L fixed at both ends. So this is A and this is B. Is subjected to a twisting moment at point C. Somewhere there is a point C here. It has been subjected to twisting at point C, which is at a distance L by 5 from A, and remaining will become 4L by 5 from B. So now the torsional stresses in the parts AC and CB will be. So first of all, we need to calculate reaction here. Now TAC will become T into the other length will become 4L by 5 divided by L. So it is 4T by 5. And TBC will become T into the other distance is L by 5 by L. So it will become T by 5. So from the expression T by J is equal to tau by R, that is T directly proportional to tau. Here the ratios are 4:1 in the form of torque. As torque is directly proportional to shear stress, the shear stresses developed in the portion AC as well as in the BC are in the ratio of 4:1. So the answer C for question number 6. Coming to question number 7, find the maximum torque that can be applied safely to a shaft of diameter D is equal to 300 mm. The permissible angle of twist theta is equal to 1.5 degrees, that is pi by 180. It will be 0.0262 radians. And length L will become 7500 mm. And tau maximum shear stress is equal to 40 MPa. And modulus of rigidity G is equal to 84.4 GPa. Clear? So from this expression T by J is equal to tau by R. So we need to calculate T is equal to J into tau by R. So that J will become pi into 300 power 4 divided by 32 into tau will be 40 divided by R is equal to 300 by 2. So that is equal to 2120575 04.1 Newton mm. So I am converting this into 212.05 kilonewton meter. Okay, so the answer will become Option A for question number 7. Coming to question number 8. In a torsion test, a specimen of a hollow shaft is 50 mm external diameter, that is capital D is 50 mm, and internal diameter small d is equal to 30 mm, and applied torque is T is equal to 1.6 kilonewton meter, and theta is equal to 0.5 degrees, that is into pi by 180 it will become 0.00873 radians. Now L is equal to length L is equal to 0.2 meter, that is 200 mm, and he has given E is equal to 2 into 10 power 5 Newton per mm square. So the question is, we need to calculate the Poisson's ratio for the given problem. Okay, so now we know the expression T by J is equal to G theta by L. So that is T is equal to 1.6 into 10 power 6, J is equal to pi by 32, 50 power 4 minus 30 power 4. So G theta is 0.00873, L is equal to 200. So from this expression you will get G is equal to 68633.63 Newton per mm square. So we already know the formula E is equal to the relation between modulus of elasticity and the modulus of rigidity. E is equal to 2G into 1 plus mu. So from this mu is equal to E by 2G minus 1. So E is equal to 2 into 10 power 5 minus 2 into 68633.63 minus 1. You will get mu is equal to 0.457. So the answer will become option C for question number 8. Coming to question number 9. Torsional stiffness can be expressed as, so you know the formula T by J is equal to G theta by L. Torsional stiffness, generally stiffness is load per unit deflection or torque per unit rotation, that is T by theta is equal to Gj divided by L. So option A for question number 9. Coming to question number 10, the stress state in a cross section of a circular shaft is subjected to a torque. For example, I have taken a shaft of diameter D and length L subjected to a torque T. So in this case there is no bending moment, there is no shear stress, only shear stress will get occur. So option C for question number 10. Coming to question number 11. A circular rod ABC is fixed at A and C. So this is A and it is C, and somewhere there is a point B at a distance L by 2 from both faces. He applied a torque T at point B, and the portion AB has modulus of that is polar moment of inertia is 3J, and BC has J. Now what is the angle of twist? Theta is equal to question mark. So as it is a parallel connection, the angle of rotation in the two bodies is same, that is theta AB is equal to theta BC. Theta AB is TL by GJ AB. Theta BC is TL by GJ BC. So now TAB and length is same on the both sides. I am getting cancelled. It is GAB JAB. So that is equal to TBC GBC JBC. So now from this expression, here JAB is equal to 3J. Here J is equal to only J. So G is cancelled. So you will get TAB is equal to 3 times TBC. So generally total torque T is equal to TAB plus TBC. So from the expression TAB is equal to 3 times TBC. So plus TBC. So you will finally get TBC is equal to T by 4. So by putting in the equation, TAB will become 3T by 4. So these are all the amount of torque that we have applied. So now the angle of twist we can calculate either of the one. So angle of twist theta AB is equal to TAB LAB divided by GAB and JAB. So in the portion AB, the torque is 3T by 4 and L is L by 2. So J is equal to 3J. So you will get the angle of twist theta AB is equal to TL by 8 GJ. Okay. So the option for question number 11 is B. So now coming to, he applied torque at this point 12,000 kg meter and at this point 24,000 kg meter. He applied the torque in the same direction. So we will get reaction here and we will get reaction torques here. So now he has given A is equal to 75. He has given B is equal to 125. He has given C is equal to 100. Now I will place only 12,000 torque and I will remove 24,000. Because of 12,000, I get torque on left portion is T1, that is equal to 12,000 is the applied torque and the distance on right side is 125 plus 100, that is 225, and the total length will become 300. It will be 9,000. So that is because of 12,000 kg centimeter, the amount of torque that I got on left side is 9,000. And now because of 24,000, the amount of torque that I got on left side is 24,000 I applied and the right side distance is 100 and the total distance is 300. So it will become 8,000. So total T1 will become 9,000 plus 8,000. It is 9 plus 8, 16 and 17,000. Okay. Similarly, T2, because of 12,000 kg centimeter, you will get it is 3,000. And T2, you will get this is 16,000. Total, you will get T2 as 16 plus 3, it is 19,000. So now the amount of torque, here it is 17,000, here it is 19,000, here 12,000, here 24,000. So now in this portion, torque is either we can see on left or right. So it is 17,000. That is in the portion A, the amount of torque is 17. And in this portion, I will calculate from left, 17 and minus 12. So 17 minus 12 into 1000. So it will become 5,000 in the portion B. And now in the portion C, it is 17 minus 12 minus 24. So this will become 19,000. Okay. So answer C for question number 12. Now coming to last question. There is a compound shaft by steel and aluminium. He has given the dimensions. So what he asked is the maximum torque that can be applied in the disc very safely is. So all the data he has given. First of all, total torque T is equal to the amount of torque resisted by aluminium and the amount of torque resisted by steel. And as it is a parallel connection, that is one shaft is placed in another, this comes under parallel connection. Angle of twist in the aluminium is equal to angle of twist in the steel. Now as length of both the elements are same, TAL divided by GAL into JAL, that is equal to TST divided by GST into JST. So you will get J of aluminium and J of steel. So J of aluminium is equal to 2.003 into 10 power minus 6. So this you will get by using pi d power 4 divided by 32 capital D power 4 minus small d power 4. Okay. So for steel it will become 0.614 into 10 power minus 6. It is meter power 4. It is meter power 4. Now T aluminium divided by T steel is equal to GAL into JAL divided by GST into JST. So you will get it is 1.144. Okay, so this ratio. So now this will become TST is equal to 0.467 into T0. TAL is equal to 0.533 into T naught. So now there are he given two materials, one is steel and other is aluminum. Now the case 1, when maximum permissible stress reached in steel, that is in the steel material I am taking maximum permissible stress has been reached. Now TST into RST divided by JST is equal to tau ST. So from this expression we will get T naught is equal to 10.53 kilonewton meter. So this is the answer that we got when the steel reached maximum. And now when aluminum reached maximum, so we got T naught is equal to 7.89 kilonewton meter. So out of these two, we need to take minimum value, because whenever we apply 10.53, aluminum will get failed. Whenever we apply 7.89 kilonewton, steel will get not failed. Okay, because it is lesser than the steel. So the answer for this question is 7.89 kilonewton meter. So this will be option D for question number 11. Okay, thank you.